topic we are going to be looking at is equal loudness curves. This is an important topic in the sense that you will get a lot of 1 mark, 2 mark questions from this topic. So, equal loudness curve capture the frequency response of our ears and its variation with increase in intensity. What does that mean? At different frequency levels, how sensitive our ears are to a sound wave. And how does this vary across intensity? That is what it captures. Meaning, let's say I have a sound source which generates a sound at 40 hertz, another source at 80 hertz, and another source at 100 or 120 hertz. So, how clearly will my ear be able to perceive each of these sounds at different loudness levels, different intensity levels? So it basically represents how well your ear is able to perceive sound at different frequencies and different intensity levels. So you can see frequency on the x-axis and intensity on the y-axis. So intensity, the usual intensity in decibels, this is actually intensity level, not intensity, so don't get confused. So the left side talks about intensity level or loudness, and the x-axis talks about the frequency. So frequency, normally we can hear from 20 to 20,000. So yeah, 20 will be somewhere around here and 20,000 is this end. And loudness level, the maximum loudness that a human ear is capable of hearing is 120. We saw the maximum intensity and pressure in the previous slide, in the previous PPT. So based on that, if you calculate maximum loudness, 120 decibels is what you will get. So what we see is that across different frequency levels, the graph follows a more or less same shape. So the thing is, at higher loudness levels, you can perceive the sound very easily. But as your loudness comes down to, let's say 20 decibels, 40 decibels, you can perceive only high frequency sounds better. For example, you take a 20 or 40 hertz sound, you cannot perceive it at all at low volumes. You need it to be really high volume to be able to perceive it. Whereas you take some 10,000 hertz or something around that range, even at a 20 decibel volume, you can be able to perceive it. So in simple terms, in terms of our everyday understanding of sound, let's say someone has a very shrill, high-pitched voice. Even if that person is talking in a whisper, you will be able to understand it rather clearly. But if someone has a very deep, low-pitched voice, you want them to actually talk loud and clear. That is when you will be able to understand. Otherwise, you can make out that this person is saying something, but you will not be able to discern the words, right? So that is what it means. If the pitch or the frequency is high, I can clearly make out sound even if my loudness is low. Whereas if it is a low pitch sound, it has to be really high, otherwise I cannot understand it clearly. So that is one thing. The next thing is around the 1000 to 4000 hertz range, there is a dip in this curve at every intensity level. What does this mean? If my sound lies in the 1000 to 4000 hertz frequency range, I can hear it even at lower levels than the other regions. So this basically one curve represents one sound wave. So if it belongs to this frequency region, I can hear it even at lower loudness levels than normal. Meaning, let's say we have 3 people. One person is talking at some 20-25 hertz frequency. One person is talking around 1500-2000 hertz, and the other is talking at 10,000 hertz. It is not possible for a human voice to generate all these frequencies, but for example's sake, we'll assume that. So what this says is, if this person is talking at 25 hertz, he or she needs to be really loud, otherwise I cannot understand what they're saying. This person is talking at 20,000 or close to that frequency. Even if he or she is going to whisper, I can make out more or less clearly what they're saying. And if this person is talking at 1000 to 4000, they can be a little less louder than the normal volume. I will still be able to understand what they're saying. Why is that? Because the human ear, normally we have hair in our auditory canal called the cilia, and this cilia, they have a frequency of vibration that is around 1000 to 4000 hertz. So when a sound wave which is also in this frequency range enters my ear, there is resonance, meaning the frequency of the sound wave and the frequency of my auditory canal cilia, they match. They both start vibrating extra. So even at lower loudness, my cilia amplifies that sound and makes it clearer to me. That is why there is this dip in the curve around 1000 to 4000, which indicates that the minimum loudness level I require to hear a sound in this frequency range is a little less compared to the minimum loudness level I require to hear a sound in another intensity range. So is it clear? Yeah, this slide says the same thing. Ears are more sensitive to 1 to 4 kilohertz, and at high intensities the ears have nearly equal sensitivity to all frequencies. This means at the lower levels you can see that there is quite a big difference. It's almost a U-shaped curve, but here comparatively the curve is a little more flat, meaning higher the loudness, you are equally able to perceive all frequencies. So if someone is talking at 120 decibels, you can definitely hear them clearly irrespective of whether it is 20 hertz or 20,000 hertz. But if their loudness level is lower, then you can only hear it if the pitch is really high. So at higher intensities we become almost equally sensitive to everything within the audible range. That is that. And yeah, if there are two sounds close in frequency and one of them is of very high intensity, it will saturate the cilia and therefore mask the lower intensity signal. Meaning we have two sounds which are almost equal in frequency, but one of them is much louder than the other. Just give me a minute please. Okay, I'm sorry for the interruption. So I was saying, if there are two sounds, both of them let's say have more or less equal frequency, but one of them is much louder than the other, then both the sound waves will enter your ear, but you will only be able to hear the louder one. The lower one will be masked. Why does this happen? Because the cilia is saturated. The cilia again is the hair in your auditory canal. It gets saturated by the vibrations of the high intensity one. So that is the only one which will be perceived. Meaning, for example, you are speaking to your friends and there is a very loudspeaker or something blaring in the background. You will only be able to hear the loudspeaker if it is really loud. I'm saying if it is at a close enough distance and the music on the speaker is really loud, you will not be able to hear your friend although he or she is seated right in front of you. You will have to either make out from their lip movements what they are saying, or you will have to ask them to repeat. So why does this happen? Although both sounds are of more or less same frequency, the audible range, the one which is much higher in loudness saturates your cilia, because of which the lower one gets masked or covered. That is sound masking. Yeah, so these two are additional, you don't need this. So any questions?